So, just for the people online, if you didn't hear what I said earlier, then I'm Mike Payne. I've been associated with the Corporate Partnership Programme in Pembroke for a very long time, and BT is one of my primary contacts in that role. BT are the absolute darling of our Corporate Partnership Programme. Been members since, I think it's about 2003, carried out a huge range of activities. It's really been an absolute wondrous intellectual exchange between academics and people in companies. Many of my students have had the real benefit of going and doing internships with BT at Astral Park, and that has been of enormous benefit to all of them. So we're very grateful to BT for what they've done for us, and one of the flagship events is this now yearly BT lecture. I mean, obviously the ones in the past, I mean, many of them have focused on the technical side around telecoms, mobile, cybersecurity, but it has moved into other areas as well. A couple of years ago, we had a talk about BT's response to COVID, and all I can say is, I just wish that Johnson had got rid of all of his advisors, brought in BT, and the country would have been in a much better place as a result of it. Okay. Anyway, this is enough from me. So it gives me great pleasure to introduce our speaker, Maria Cuevas. So she leads the Networks Research Directorate in BT's Research and Network Strategy Group. And there's lots of brilliant things she's done. I think you've been at BT for 23 years, is it? Oh, that's nothing. I've been here for 45. No. So, really looking forward to your talk. But the one thing I really wanted to pick out from a very extensive and very distinguished CV is the fact that you got the award of Women in Telecoms award. So congratulations for that, and we're very much looking forward to your talk, which is on building future mobile networks. Thank you, Maria.
Thank you very much. Well, thank you for having me here tonight. It is my third year attending the previous 2 years this lecture. I've very much enjoyed it, and it is my pleasure and my honor to be here tonight. I'm going to be talking about the future of mobile networks, but before I talk about the future, I'll probably talk about the past a little bit as well. So I would like to perhaps recap a little bit, and for some of you, the younger audience, you might not remember, you won't remember all of this, so hopefully it will be informative and fun. What has been the journey from the first generation of mobile to where we are now. A little bit of what does a mobile network look like for those of you in the audience who might not perhaps be on the inside of this industry. Just for you to know what happens to the data when it leaves your phones and where it goes from there. And then, of course, about technology, right? What are the advances that have been underpinning mobile evolution up until now? I'll talk about where we are on the journey. So obviously, BT being a big operator in the UK, we have a big rollout of 5G at present. So I'll give you some detail on that. And interestingly, and obviously looking into the future, what are we looking for in future generations of mobile? Before I start, and yes, I've been in BT for 23 years. Most of my background is actually mobile technology. I've probably been in the industry since the early days of 3G. But of course, in my teenage years, I knew 2G and first G, and that's probably where I got interested, if you like, in this whole industry. I'm a passionate for technology, but overall, I'm a passionate for the impact that technology has on people. So hopefully today I'm going to cover a bit of both the technology underpinning, but also what it means to people's lives and businesses all across the UK and obviously on a global basis. Right, so if you Google the journey of mobile, you'll find loads and loads of diagrams like this. They tend to give you a bit of a gist of the timings of the different generations. And of course, it goes into devices and services. So the first thing to notice about these kind of generational cycles is that they're roughly about 10 years. The reason why it takes 10 years actually to go from one generation to the next one is because there is a lot of research happening, and I will be talking later about how we are contributing to the research across the UK and on a global basis towards 6G. Then it needs to go to standards. There are international bodies that take effectively those technologies and make sure that a mobile phone can talk to a mobile network, And when you travel abroad, your phone will work with any network out there. So that's what those international standards are for. And then, of course, our suppliers have to develop products. Those products have to be built, and they need to be tested, and eventually they make it into deployment into our networks. That roughly takes about 10 years. There are other aspects of technology that require, again, you know, a fairly long cycle. Things like the evolution of semiconductors. We need a lot of processing power on the cell sites and on the mobile phones to be able to cope with the new generation. And the other one is that there is a spectrum that needs to be allocated to different generations, and that takes a lot of discussion across industry on a global basis as well as on a per country basis to be able to allocate the right frequencies to the right technology. I'll talk a little bit more about that later. The next thing you'll notice across the generations, and this is where it gets a little bit funny because some of you won't recognize or won't have seen a mobile phone that came with a backpack, which was a big battery of the size of a briefcase. And that was actually the first generation of mobile. Very few people had it. You had to be very wealthy and have very special needs. And normally actually was attached to a car because really pretty much the battery wouldn't last for too long. Is when it came to 2G that phones started to become a lot smaller actually, and obviously self-sufficient from a battery perspective. And I will talk a little bit later about why and how that happened. With 3G, again, you may or may not have come across these form factors, but there was a BlackBerry which had a little keyboard because touch screens didn't exist. And then, of course, with 4G, we started to see, if you like, the modern smartphones that we have today with touch screens and obviously iPads, and then we started to see wearables and so on. And now with 5G, and I will talk a little bit more about the types of services and devices later on, but with 5G it's anything. It's not just about smartphones, it can be drones, it can be cars, it will be about sensors. It's effectively anything that can be wirelessly connected and will deliver a service or value to a customer can be connected via 5G. But we'll come back to some of those later. And what that underpins is effectively the services and the value that we deliver to the customers. So again, if we go back to the first generation of mobile, it was all about voice. And then it got better because voice quality actually improved significantly in 2G, but also we could send text messages. Surprise, surprise, SMS. Before the days of WhatsApp, there was something called SMS that a lot of people used a lot, and still use a lot actually on a daily basis. 3G started to provide internet access. It was obviously the early days of having general access to the internet, and of course mobile networks needed to evolve to support that connectivity. But it's when 4G obviously emerged, and with the emergence of the iPhone and the App Store, and of course then we had Android and other operating systems, with all those apps and all that content that started to become available, higher data speeds became obviously a necessity. And we also started to see the need for things to be connected, and that's where, if you've heard the term Internet of Things, is where anything around you can actually be connected. 5G is actually about taking that connectivity of things to a massive scale, and that's where we talk about massive machine communications. And the other thing that 5G brings is what we call mission critical services. This is well beyond your smartphones of today. This is actually where we help businesses and industries around the world actually do their jobs much better. I'm going to bring some examples later to what mission critical services actually mean. And of course, a lot of that is underpinned by technology and technology evolution. I'll touch on some of these later. For, again, anybody in the audience who might not be familiar with some of these capabilities, I'll talk about what difference there was when we moved from analog to digital, and perhaps from circuit switch to IP routing. But obviously, more recently, how can we actually achieve bandwidths and speeds which are much greater than what we've had in previous generations. And finally, actually with 5G, how can we improve latency? And for those of you who play on the internet, you will know it as ping. The time it takes a packet to get from your PC to the internet and back is pretty much what we call a latency requirement, and I will explain how that obviously it becomes very important for some of the mission critical services that 5G brings. And last but not least is adoption, which obviously comes with the impact that these technologies are having in people's lives. If you look at the numbers in terms of global mobile subscriptions, we were on the 30 million-ish in the early 90s. If we fast forward to 2020, actually in the early days of 5G, we were about 8.2 billion mobile subscriptions around the planet. That's more than one device per person on the planet, which is massive. And of course, if we look at forecast, and this is coming from an Ericsson report that every year gets published, effectively the forecast is that everything is going to grow dramatically. So if you look at, I think I have a pointer, if you look at 2023, which is around here, we're on 150 exabytes. If anybody doesn't know what an exabyte is 1,000 petabytes or 1 billion gigabytes. It's an awful lot of traffic actually being handled over mobile networks globally. Now, if you look at 2028, that's going well over around 460 exabytes. Actually, to bring it to life a little bit, if we look at, for instance, the average usage in Western Europe, again, today is about 30 gigabits per second, just a little bit below that. If you translate that into HD video downloads, it turns out to be about 40 hours of HD video that people download on a monthly basis over mobile networks. And obviously, it's not just video, it's many other types of traffic. And the last thing to say, and just to remember this Internet of Things emergence that we've discussed, today we're at about 3 billion Internet of Things, or things connected over the Internet, over mobile networks. In 2028, we're talking almost 5.5 billion global connections. So that's just to give you a feel for, obviously, how demand is expected to grow, and therefore, we need to meet that demand, and what are we doing about it. Before I go on to technology, and again, some of you know this, of course, very, very well, but a lot of people, perhaps, when they use their mobile phone today, don't necessarily know what happens to that traffic. So first, we have devices, and as I said, devices is not just a smartphone. It can be a watch, it can be a car, it can be a VR headset or an AR headset. One thing that all devices have in common is, one is the SIM module. This is that little card that you will insert into a slot on the phone. That stands for Subscriber Identity Module. That tells us, as the mobile operator, who you are, whether you've paid your subscription, what type of subscription you're having, and what services you're entitled to have. And the other thing that the devices have is a radio modem. And of course, the radio modem will actually create, if you like, the signals that go over the radio channel and get transmitted over the network. The other important, very, very important part of a mobile network is the radio channel. That's obviously where the radio waves are transmitted from the base station to the device, and is obviously a radio channel with a set of characteristics. I spoke earlier about spectrum and frequency bands, and this is where it becomes really, really important what frequency band you're using for each technology. So one thing to know about frequency bands, and apologies because that is a little bit faint, but hopefully you can almost tell that there is a wave going up and down here. Depending on which frequency band you're operating in, the distance between the peaks gets smaller, actually, the higher the frequency goes. What that means is that your wavelength becomes smaller, and that has a huge impact on the propagation characteristics of that wave. And in essence, what that means is that the higher the frequency, the shorter the distance that a wave can reach. That's really important for coverage. When we deploy a cell site, one of these things, depending on what frequency we operate at, effectively the signal will travel long or less of a distance. And of course, it also matters in terms of propagation into buildings. So the ability for that wave to go across the walls is very, very different depending on the frequency. And again, the rule of thumb is that the higher the frequency, the harder it gets. But we still use, obviously, frequencies because they are very valuable to us as mobile operators, and we make the best use of them depending on the environment and the coverage that we're trying to provide. So going on to what happens to that radio wave, it gets onto what we call a cell site. These come in different sizes, macro, small, femto, depending on whether it's a big mast, trying to obviously provide coverage to a very, very wide area, or it could actually be a smaller cell which could go on a lamppost or any other street furniture to be able to provide capacity to urban areas where there are loads of people at any point in time trying to use their mobile phones. And of course we have antennas and a lot of radio equipment. I'll come to actually some of the technological advances as well that require, again, those antennas and those base stations to provide more capacity over time. That packet that left your phone a while ago has to actually go over a set of transmission networks. This is a huge network across the entire country, mostly actually carried over fiber these days because we need a lot of capacity to carry that traffic, but some bits of it actually can go over wireless links, and you will see, if you like, some of the dishes being point-to-point links that carry all that traffic from one place to another. But as I said, the key thing about the transmission network is the amount of capacity that it has to carry over time. Last but not least, it gets onto the mobile network. This is obviously one of, for an operator, is actually a key a bit of our infrastructure. This is where we actually take that module that we discussed earlier, and we take the information. The information travels all the way to the mobile core, and we're able to authenticate the subscriber. We can tell that you are who you say you are. We can tell that you've paid your bill, and we can tell that you are entitled to have certain services. It could be voice, SMS, data, you name it. And the other thing that we have to do is manage mobility, because of course people move around, and depending on which cell site is closer to them at any point in time, we need to make sure that we carry the traffic over to the new cell site. If you've been moving at a pace or at a distance or at a particular speed, we're always able to serve the traffic to wherever the mobile device happens to be. And that's really important, obviously, in mobile networks. Once the operator domain is almost finished, we obviously have to carry the data. If you're accessing the internet, if you're going to a Netflix site, if you're going to a Facebook page, most likely the content will be stored somewhere around the planet. In some cases, it's actually stored in the operator's network, but in many, many cases, the content itself might be elsewhere. So we need to be able to route that traffic over the internet. So we have all sorts of connections, internet peering points. Obviously, a lot of that traffic is carried over subsea cables if the data center happens to be in another geography. And again, there is an awful lot of infrastructure going across the entire global internet to make that happen. And the last thing to say about a mobile network is that increasingly, actually, what we're doing is serving private connectivity for business customers. So in a lot of cases, actually, the traffic might actually not be getting anywhere near the internet, because it might actually be routed straight onto a customer site if that is actually one of their needs. So enough about a mobile network. I can come back to that if you have any questions later, but hopefully that gives you a little bit of a gist of what's inside a mobile network. Right, so as I said, still in the kind of past, but I think a lot of these technological advances we may not realize today actually made a huge difference to mobile communications as we know them today. So I wanted to give you a little bit of a flavor of some of those. We cannot describe them all today. But I think I've mentioned already actually the move from analog to digital. And a lot of you will be familiar with, obviously, those terms. What's important to know is that when we moved from the first generation of mobile onto the second generation, the fundamental shift that happened is that voice, instead of being encoded as a wave, as you can see here, was actually encoded in what we call a digital signal. The key difference is that a digital signal has a set of discrete numbers or values, actually, that can be carried over the radio. And that makes it very, very tolerant to noise, which is why the digital voice is actually much clearer than analog voice. So that was one of the key advantages in terms of giving much better quality to our customers. But the other key advantage is actually that it's a lot more efficient. So we're able to carry a lot more, many, many more voice calls or data, actually, if we move into future generations over the radio by moving, as I said, from an analog signal to a digital signal. The other key advantage, which I mentioned briefly earlier, was battery life, and actually one of the key reasons why actually phones started to become smaller is not just obviously the evolution of batteries themselves, but it's also the fact that digital voice was a lot more efficient from a battery consumption perspective. So that's one, if you like, key example. Another important one, which kind of happened between 2G and then moving on to 3G and eventually the fourth generation of mobile, is the evolution from circuit switching to packet switching. Now, circuit switching is effectively how voice traffic was handled. And some of you may have seen movies where there is a lady in front of a switchboard plugging cables on a board in front of them. That was actually switching a circuit manually. That was obviously the days of fixed only voice. But the concept was still the same for a number of years, which was in order to make a call, you had to reserve a path, a physical channel between A and B, and that channel would have to be reserved and dedicated to that voice communication for the duration of the call. And then, of course, when the call was cleared, the path would be released. That's not very efficient. So what happened when we moved to packet switching is that information, and that's the basis of the internet today. What we do is we take any type of information, or it could be voice, or it could be data. We turn it into small packets, and those small packets can be sent across any route over the network, so long as they get to the other end, where they get reassembled, and obviously the data gets reconstructed. Now, again, might not sound like a big thing, but it is actually, as I say, one of the fundamental principles of the internet and the way mobile communications work today. We moved very much from a voice-oriented architecture to a data-oriented architecture. And that allowed us to, again, increase the scalability, the flexibility, and the cost of mobile communications. So again, massive shift and massive difference to the way we do things today. Fast forwarding on to perhaps two more technologies which are very, very key to effectively 5G and now, and we are actually embarked on that journey right now. If you remember, I talked about the antennas and the base stations and those big masts that we see on the road when we drive along the road. And they've become bigger, actually. If you look at the panels themselves, they have actually, many, many cases become bigger. Now, that is a good thing, and they are bigger not just for the sake of it. They are actually, because they are actually containing an awful lot more active circuit components inside them. That's pretty much the result of 40 years of research and advances in semiconductor technology. And what that does is effectively have many more what we call receive-transmit chains inside the panel, and will enable us to use the spectrum that we have many, many times over, so that we're able to actually send stream 1 and stream 2 are effectively 2 bits of data. We're actually able to use the same spectrum over and over again from the same panel, just by having those active components actively built onto the panel itself, as opposed to what was happening before, where a lot of the power amplifiers were actually happening at the end of a coax cable, which was actually losing a lot of the power along the way. So it's a very, very high level description of how this works. There is an awful lot more science behind it. But effectively what we achieve is what we call a spatial multiplexing. So we're able effectively to multiplex and to reuse the spectrum that we have. And if you hear a term called MIMO, which it stands for multiple input, multiple outputs, that's effectively what is the advantage of, or the product of active antenna systems. The last thing I'll say, and still referring to, again, some of the past, but actually this is more present than past, if I'm honest, because we're actually in the middle of doing a lot of this, is what we call cloudification of the network. So obviously everybody has heard about the cloud. The cloud is not just about having data in a data center somewhere remotely located. The cloud has brought a lot of technological advances that we can now actually leverage in other industries such as telecoms. So for us, if you remember that mobile core that I talked about earlier, but increasingly actually some of the radio components are becoming software. They're becoming software components which can move from being what we used to have as a vertically integrated solution, where if you wanted to bring a new function into the network, you brought a new box with a certain amount of capacity, and it was dedicated to that functionality and that functionality only. We are now starting to migrate into a world where, as I say, functions become software, and they can reuse the underlying infrastructure. This brings massive amount of flexibility in the way we build our networks. But the most interesting thing is how it enables us to introduce new services much more rapidly. We're right in the middle of this journey. We are actually migrating our networks as we speak today. And if you hear you will actually hear a lot of announcements from BT and other operators about how we're modernizing our networks to be cloud native effectively, which is what this is all about. So that was a little bit on the, if you like, the history and the technologies underpinning that history. And if we look at where we are now, and obviously BT being the largest mobile operator and fixed operator in the UK, our brand EE for mobile communications, you're probably familiar with it. We've actually won the Best Network Award for 10 years in a row now. This is actually a benchmarking where an external company called Root Matrix takes tests across the network in many different locations. They take tests across all UK operators, and they come up with a ranking that tells us who's providing the best experience across the UK. Very proud of that. Also very proud, obviously, of the journey in terms of the coverage that we can offer. So we offer 99% of the population coverage is now 4G. Now, one very important thing to say is that obviously 4G is still very important. We continue to invest in it. An awful lot of the things that you will do on a daily basis, actually 4G is very capable of carrying traffic for those, so we continue to roll that out. And of course, we have 5G evolving. Actually, the fastest evolving technology so far has been 5G. So we have 70% of the population now covered with 5G, and we've actually made, we have an ambition and a target to address 90% of the geography in the UK with 5G by 2028. So that's a little bit of where we are on the journey, and as I said, a lot of technology and a lot of evolution happening behind that. But if you remember, I spoke about 5G being much more than just obviously about smartphones and about higher speeds and higher capacity. So with 5G and obviously any future evolution of our mobile networks, what we look at is a myriad of services to many different industries, many different sectors, and actually very much about trying to improve the way they work and having effectively a set of solutions that can meet and be tailored to the needs of those customers. Ports is a huge area for us. We have deals with Belfast Harbour and Port of Tyne are two that I know we have announced, but we have many, many other, if you like, customer conversations, trials, and very active engagement with, as I said, that the whole area of ports, transport, and logistics. And just to give you an example of some of the use cases and the services that we deliver to those customers, they use drones for surveillance. So you might have a camera on a drone that is flying over the port and is sending in real time the video footage from the area. That may be used not just for surveillance and security purposes, it can also be used for inspections, fault detection, and of course it makes it a lot easier and a lot cheaper to detect and inspect and repair faults across the site. We also work with manufacturing customers. A lot of them are obviously going through massive journeys in terms of automation. And of course, wireless connectivity becomes a huge enabler for wireless automation, especially when robots have to move across a factory floor. You don't want to have to wire those, and therefore wireless connectivity, highly reliable wireless connectivity, becomes absolutely key. I can give many more examples. We've worked with health actually and with the NHS on various trials and pilots to do with remote diagnostics and how can you actually improve the way, again, the NHS does their job, but also, anything from delivery of medical supplies, which again we have done in a number of occasions, using drones or using autonomous robots for that. And last but not least, agriculture. Again, you know, it might not be a field where you think actually there is so much technology, but actually agriculture is becoming a hugely technology field, and the use of autonomous vehicles. Also the use of inspection, very, very similar to what we're doing with ports, but how can you actually inspect the crops and decide if they rip, if they need more fertilizers, you know, what sort of treatment is required, is becoming all about automation and about optimization of their operations, which at the end of the day is what they want to achieve. And of course, all of this is accelerating, and again, 5G is starting to make it happen, but of course there is an awful lot more coming. Right, so where are we going next, you might ask, and of course we are still evolving 5G. We haven't stopped to not just deploy but modernize our 5G network, but we're starting to think about 6G, and we're at a very early stage in the 6G journey. We're starting at it from a research perspective, but now is a really, really good time to be taking a step back and thinking about what are the real world needs that we need to address with this evolution of the technology. So on the one hand, thinking about the demand from the customer side, just before we started, we were talking about reliability and coverage actually, and how a lot of that is still needs to be improved. So pretty much customers want reliability. They want to have the ability to access their services wherever they need them, whenever they need them, and that's definitely about improvements in that area. I'll come back later to some of the things that we're doing in that space. The other thing that customers want is not to have to worry about connectivity, is that seamless experience where it doesn't matter where I am, whether I'm indoors or in a rural area or out and about or in a very busy city center. I don't want to have to select which network I'm connected to. I don't want to have to log on to Wi-Fi. I mean, it may or may not work. And then of course log off or switch off Wi-Fi if for any reason I happen to be at the edge of that Wi-Fi access point coverage and my experience is not as good as it should be. So that kind of ability to connect to any access network around me without me knowing as a customer that I need to do something on my device is absolutely key. I've talked about outcome or solutions effectively for customer needs, especially in an enterprise and a business context. This is absolutely key. Customers want stuff now, and they want it on demand, and they want to consume it, and they want it to evolve to meet their needs of the future. So being future-proof is absolutely key. And last but not least, they want best value for money, okay? And as we've seen, obviously the demand keeps growing. Everybody wants to access more data, more services from their devices, but nobody wants to effectively that to go for a very, very high price tag. So we have to make sure that we are actually obviously adjusting, if you like, the pricing to the value that customers are demanding. So in that context, we have a number of challenges and things that we as operators need to overcome. Every new technology, and this is not just when we introduce a new generation, but new technology introduction comes at a cost. And it can potentially, if it is not done correctly, it can introduce disruption. That's something we absolutely must avoid. Every generation has to avoid causing any disruption to previous services and of course to the experience that we offer to customers. So that's still something that is key and we need to continue to provide. We also, and I'll talk a little about energy consumption and some of those things later, but actually legacy networks, if you look at our networks now, we're having to do all generations actually, well, except for the first one actually, which we got rid of a while ago. And that becomes very expensive. It becomes expensive to maintain and operate, but it's actually not very energy efficient. So that's something that we absolutely need to address. We will look at some ways that we're looking at doing that right now. And of course, supply chain is becoming increasingly a potential problem. It's obviously not an immediate one, but it could become one, and especially when we look at geopolitics and the current situation around the globe, and a lot of the uncertainties are actually impacting our suppliers, and that is something that we need to be very conscious of. And last but not least, I spoke about sustainability and about energy efficiency. And just to give you some, just tying that up to the comment I made about legacy networks earlier, BT has announced that we're switching off our 3G network next year. The reason why we're doing that is that 3G at present carries only 2% of the data over our network, but it happens to consume 35% of the energy over our radio. So just those two numbers will give you a gist of how, if you like, the evolution onto new technologies has become a lot more energy efficient, and therefore it's a very good idea to be thinking about turning off those legacy networks. So, and in this context of everything that is happening, of course, in the mobile world, I think one very important thing to realize is that obviously telecoms doesn't exist in a bubble, and we have to actually leverage external technologies. We have to look at them from many different perspectives. One is obviously what impact are those technologies going to have on our networks and our industry. But we also need to look at how to make the best use possible of those technologies. And here are three examples. There are many other things. I've mentioned semiconductors and cloudification in the previous section. But now if we look into the future, I'm sure nobody has missed the evolution of artificial intelligence and all of the information, if you like, around us, whether it's ChatGPT, generative AI, obviously both from the risk of those technologies not being properly used and regulated, but also obviously the benefits that they can bring to society, which is really, really exciting, and is effectively at a tipping point, we feel, these days. From our perspective, we're obviously investing a lot of time and effort into what do those technologies mean for us. If I focus on the mobile network, because of course BT is doing many other things, but just looking at the mobile network, we have to figure out how much of that data is going to be carried over our network. You might actually argue that there is going to be less traffic over our networks because devices become a lot more intelligent and autonomous and can make decisions on their own. However, there are many different ways and models of AI where perhaps training data might actually be carried over our networks, especially if the way the training evolves in the future in a particular direction. It's not just about training data, it's obviously about where the artificial intelligence logic actually resides. There are models actually where if devices have to be low cost, the artificial intelligence and the workloads might actually be in the network, and that could actually have a huge impact on the amount of traffic that we have to carry over our networks. Not just the amount of traffic, but things like the latency and the speed of response, if you like, when a device is trying to consult with a piece of logic in the network about where to go next. That's just one aspect, as I said, from an impact perspective, but what we also are very keen on is actually exploiting AI. And the obvious example is how are we going to operate our networks in the future. Our networks are becoming a lot more complex. A lot of those services that I've been discussing are effectively having very different requirements, whether it's for latency, capacity, speed, and we have to handle effectively all those stringent requirements, and they will coexist, and they will make these networks very, very complex. The good news is a lot of these machine learning, AI algorithms can help us with that problem. It's very hard to tell to what extent we will have fully autonomous networks in the future. The mainstream of thinking says that there will always be a human in the loop somewhere making the ultimate decision, but to be honest, I don't think anybody knows the answer to that question just yet. But the evolution has to be for more automation in the network and actually making better decisions about how we detect faults, how we improve customer experience, how we deliver service level agreements in a very dynamic way, and also how do we predict faults in a way where before they even affect a customer, we can actually fix something before it happens. So anyway, a world of things to look at there, but a very exciting technology and one that we absolutely need to leverage and enjoy. Satellite is the second example, and you probably have come across some announcements, especially in the US, but it's coming to Europe very soon, in terms of services that already actually allow a mobile device to connect to satellite. Up until now, the biggest problem has been cost, the cost of launching and operating a satellite. But actually those costs are becoming obviously are going down, and that brings an opportunity for communications to actually integrate what's happening in what we call non-terrestrial communications. That could be geosatellites, it could be low Earth orbit, or it could actually be high altitude platforms, which are a lot closer to the surface of the Earth. But in essence, that is actually going to address a lot of the problems that we have with coverage, and we do believe that the right integration between those and the terrestrial networks can actually be a very good answer to that. Last but not least, in terms of, again, surrounding technologies, is quantum. Some of you are probably familiar or even involved in research in that space. And again, quantum computing, again, very, very similar to many other technologies. It can either be, seen as a threat, and of course, from a security perspective, we are absolutely very serious about knowing how to protect our networks. That is our bread and butter, and we need to continue to do that against any form of technology out there, but of course, quantum computing being the biggest one, if you like, emerging, that could pose a threat on our networks. But once again, it can become an ally. We are actually looking at ways to use quantum physics to actually protect our networks. And there are techniques, if you like. I won't go into the detail here. We're running trials where we can actually very, very securely exchange encryption keys in a way that cannot actually be tampered with. And if somebody tampers with the data or the keys that we're exchanging, we will know that somebody's trying to attack our networks. And that's a very, very powerful tool at our disposal that we are very, very actively researching and trialing now with customers. There are many other aspects of quantum which I won't go on to, but you've probably heard about quantum sensing, which is another, again, capability of quantum which we can leverage to perhaps offer new services to our customers. And quantum timing is a very, very interesting one, because what that gives us is very, very accurate timing information that we can actually use across our networks, because our base stations and our radio communications actually rely on very accurate timing. So again, a very, very different aspect of quantum that you wouldn't normally associate with telecoms, but it's actually very, very important to us. I'm not sure how I'm doing with time, but you'll keep me, yes, okay. Now, in terms of what we're doing as a research community, and obviously BT, all over the place, if you like, looking at a lot of these technologies, and especially what is it that we need to focus our efforts into, because of course there is a million things we could be doing, but we need to be doing something that makes a difference to our customers and obviously to address the challenges that we have. We're involved in a number of collaborative projects. I'm going to mention two here. One is Project Tudor. Both of these projects receive some funding from government. It's actually a mixed funding approach where government, DICIT in this case, invests in these collaborative projects, but of course all parties involved add, if you like, effort to the table. Actually, one of the key interesting things about these projects is that they involve a very large number of partners. It's not just the number, actually, it's the mix. It's a really, really good mix between universities. This particular project called Tudor is led by the University of Surrey. But then, of course, there is all sorts of different sizes of enterprises involved, from large vendors to smaller vendors to startups, and of course to operators like BT, making sure that all of these candidate technologies that we're looking at in 6G, I'll cover a couple in a minute, are actually focusing on solving real issues. I'll cover a couple later. The second project I'm going to mention, we are actually involved in many more projects, but these are probably two of the largest ones that we're involved in at present, is led out of Bristol University. It's called Reason. And again, very much focused on the evolution of future mobile networks. A lot of the things we've mentioned, like how do we actually bring together all these different access technologies to effectively become potentially technologies that can underpin 6G. How do we bring, whether it's Wi-Fi, Li-Fi, fiber, and edge computing. And one very interesting aspect of this particular project, again, is how can we use AI to manage our networks. Right, and just before I finish, I wanted to give a flavor for what do some of those candidate technologies for 6G look like. And again, this doesn't mean that this will definitely be the ones that make it into the final standard, but we're putting a lot of effort into deciding if these become highly beneficial. I've talked about AI already a little bit, but one very interesting concept is how can we use artificial intelligence to drive the way the radio channel operates. I think I've talked earlier about how frequencies, make a difference to propagation, to going through walls, etc. If I can actually use AI to actually adapt to the environment and adapt my radio to the conditions of the channel for each particular deployment at any particular point in time, I can actually, what we're hoping, right, is that we can actually improve significantly, again, the capacity and, very importantly, the efficiency of, from an energy perspective, of the way we deliver radio traffic. That's just one example of how we could potentially evolve our thinking. There is another very interesting technology called reconfigurable intelligent surfaces. This is effectively about having a programmable surface that can be controlled to effectively steer a signal. It will reflect a signal, and you can actually steer it in a particular direction. And again, this is again about improving coverage, it's about improving the signal. Everything in radio has to be about one of those things. You're either delivering more capacity to your customers, you're improving coverage, or you're improving the reliability, which in this case you can definitely improve the quality of the link by introducing some of these concepts. Obviously, a lot of the question marks are about the practicalities of these technologies. How much will it cost? What will be the challenges from a deployment perspective? So a lot of the thinking right now, and we are doing an awful lot of work in this area, is about how can we actually practically make use of these technologies in a real live network. There is another very interesting concept emerging in 6G or in the candidate technologies for 6G, which is referred to as joint communications and sensing. In essence, what that means is that the mobile network becomes like a radar technology, and it can actually sense the world around you. Ideally, effectively, what we're using is the same signal that we use to communicate to mobile devices to actually build, if you like, a map of the environment around you. You can use that for two things. You can use that to improve your radio propagation conditions again, but what you can also do is actually use that data to perhaps build a replica of your surroundings, and that's something you can use for digital twins or for many other use cases where you actually can build a real-time map of an environment using this technology. Again, very early days, hard to tell whether or not this will be practically possible, but very, very interesting. And the last one I'll mention, because there are many, many more that we are exploring, is what we call this network of networks. It's actually about having very, very open architectures where different types of communications, whether it's satellite, whether it's terrestrial, whether it's Wi-Fi inside the home, whether it's ships, using again a combination of all of the above, can actually be combined dynamically to offer the best possible solution to a customer. And again, paying special attention to energy efficiency. Again, not everything is about obviously what network do I have around me. If I have a number of networks around me, what is the most efficient path that I can use to deliver traffic to a customer? Hopefully that gives you a bit of a gist of some of the candidate technologies that we are exploring. This is the last thing that I'll say. Nobody knows what 6G is just yet. We're obviously making sure that, again, we focus in what really matters to people. Actually, one of the key things, and it's being discussed a lot, is how we need 6G to be aligned with the goals of society. And I've mentioned energy efficiency, sustainability. That is absolutely key. Not just from the amount of energy that our networks consume, but also about the services that we can offer to our customers to help them manage their energy much more efficiently. So absolutely think that this is key for the future of our industry. I've talked about coverage a lot, so that availability everywhere, every time, anywhere where you need it is again another thing that we are definitely injecting into the thinking for 6G. I've talked about how we want to and need to leverage all the key technologies around us, so whether it's artificial intelligence, quantum, anything around cloud computing, as I said, we are definitely keen to exploit the value of that. There is a lot of discussion and conversation about how the physical and the virtual worlds will come together. I tend to, or want to believe that the virtual world has to be about improving the physical world and augmenting and making it better for us. So I do believe actually that these communications can actually make our lives better and help us lead a better life. And to be honest, the last thing to say is we don't know what 6G is going to look like, but what we really don't know is the service that it is going to enable. Our ambition is that it enables the unimaginable. And with that, I'd like to thank you very much, and I'll take any questions. Thank you very much.